Ni. So they are given in terms of the number of the turns. So what is this? This is the turns per length, unit length. That's why I have to convert this Ni by N. This is the formula. So here they are given that based on the length and N. So that's why I can write my magnetic field in terms of N by N. So V1 by V2 is equals to N1 by L1 into L2 by N. So you can substitute the values and you get the answer. So 1 by 2. So basic formula is the remaining formula. Last class I have given this problem. So last class I have given this problem. So there is a solenoid. There is a solenoid I have given this. Okay. This is the solenoid they have given, and they have given the diagram. So this is the center, and there is a point here. They asked to find out what is the magnetic field at this point, and they have given this is the N turns, and this angle they have given it's a 60 degrees, and this they have given as a 20 degrees or 30 degrees. So how you solve this problem? I already given this. Let's again discuss the problem. So how to solve this problem? Just you have to write the formula. It's a mu is equals to V is equals to mu naught Ni by 4 into sine alpha plus sine beta. We already given this formula. So here, usually we have taken the alpha here. This is going to be beta. Kabatti, మనకి ఈజీగా తెలుసు this is going to be 60 and this is going to be 30. Someone? What is toroid? Yeah, we'll discuss toroid, Prachwal. Now we'll discuss the toroid. Okay, and see, we have to substitute the values mu naught Ni by 4 sine 60 plus sine 30. So if you substitute, you will get the answer mu naught Ni by 4 root 3 plus 1. And someone told there is a pi and a, no, and there is no pi, so there is only 4 and. In solenoid, this derivation it will come only 4. So last class also I given the same problem. I explained this derivation also last class. I didn't explain derivation, but the formula is the. See, in which case this pi will come. So mu is equals to mu naught Ni. So not Ni. It's a mu naught 2 pi Ni divided by 4 pi. So and they will give you this value, not 4 pi. It's pi only. This is going to be pi only. So pi and pi, and this is going to be sine alpha and sine beta. I didn't explain this derivation. There is no use of explaining this derivation at this point. That's why I didn't explain this derivation. So remember this formula. From this formula, we have to work it out on the infinite solenoid. Okay, and we have worked on the solenoid is one end is the 0 degrees, one end is the 90 degrees. That we have worked on. So now come to the concept of the toroid. See, come to the concept of toroid. So toroid is similar like a solenoid. Okay. Toroid can be ring shape. ring shaped solenoid. So if you take a solenoid, okay, this is the solenoid. If the solenoid is, if I turn like this is called toroid. So ఈ టొరాయిడ్ ఎందుకు ఏం చేస్తామంటే దిస్ టొరాయిడ్ యూజువల్లీ వీఆర్ గోయింగ్ టు యూజ్ ఇన్ ద పార్టికల్ యాక్సలరేషన్. ఎందుకంటే యాక్సలరేటర్లో సో వీఆర్ గోయింగ్ టు యూజ్ ద పార్టికల్స్ విల్ రొటేట్ లైక్ దిస్ and it will gain the acceleration, and at some point we will release the particle and it will move and it will collide the other particle and we will see the bombarding of the particle. In this case the toroid mostly they will use. So usually the diagram of the toroid will be like this. Okay, so if you take this is the diagram and the wounds are, it will wound like this on the toroid. These are the coils. Okay, na? These are the coils and it will come again, it will come. This is the current and this is the outside the current. So the radius of there is inner radius, outer radius. Usually this is going to be R, and this is called, we will call it as a winding, and this is, we will call it as a core. Yeah. Cyclotron is the mission, and yes, cyclotron is a mission. Cyclotron, if you use the toroid this in the mission, that is called cyclotron. So in the cyclotron we will use this concept, toroid concept. And it's like na toroid ante em ledhu, it's like equipment. Solenoid aithe etlagaithe oka electrical device, so toroid kuda is kind of electrical device that we are using in the cyclotron. Cyclotron is the machine. And if I draw this for more understanding, see here the windings is going to be look like this. Current is going outside and here the current is going inside. Like this you can see. See these points I am saying, these points. This is the inside and this is the outside, like this. Okay, so now see, and we are, this is the point P where we wanted to find that what is the magnetic field at this point P. So the formula is given by for this toroid is no derivation for this formula. 2 pi r, which is equals to mu naught n I. Here please see they are given the number of terms, they are not given number per unit length. Okay, so please be careful here. So in the solenoid lo manaki etla istadi mu small n I ichevadu, కాబట్టి ఇక్కడ మనకి ఏమి ఇచ్చాడు big n. Okay, big n means number of terms. So this is going to be mu naught n I divided by 2 pi r. So where now I can write this is going to be so mu n I. The same formula came like a solenoid, but here n is going to be so here my small n is going to be n by 2 pi r. So in the solenoid lo manaki so n is going to become n by n because endukante it's a length, but ikkada 2 pi r because it's a circle, so that's why 2 pi r circumferences they are given. It's a number of turns per 2 pi r. Please remember this. So this is the important thing. Here the same mu ni, in the place of n we got the n2. We will solve the two problems. Yes and no. The cyclotron is a type of a particle accelerator that uses constant magnetic field and alternating electricity to accelerate the charged particles. A spiral path is very high speed. Yeah, అదేనండి. హర్షిత్ ఏం అవసరం లేదండి, టుడే యూ నో నీట్ రైట్ ద నోట్స్, ఓకేనా? అవునండి ఖుషి, దట్స్ వై ఐ టోల్డ్ ద సైక్లోట్రాన్ ఈస్ ద మెషిన్. ఐ ఆల్రెడీ టోల్డ్ ఇట్స్ పార్టికల్ యాక్సెలరేటర్ ఓన్లీ. ఎస్. సో సైక్లోట్రాన్లో యూజ్ చేసేది ఏం యూజ్ చేస్తారు, ఇక్కడ మీరు ఒకటి చెప్పారు మ్యాగ్నెటిక్ ఫీల్డ్ అన్నారు, కాన్స్టెంట్ మ్యాగ్నెటిక్ ఫీల్డ్ అని. ఈ కాన్స్టెంట్ మ్యాగ్నెటిక్ ఫీల్డ్ ఎట్లా జనరేట్ అవుతుంది? సో బికాస్ ఆఫ్ దిస్ సైక్లోట్రాన్, ఓకేనా? సి బికాస్ ఆఫ్ దిస్ టొరాయిడ్. సైక్లోట్రాన్ అంటే ఒక బాక్స్ ఇలా, ఒక సర్కిల్ బాక్స్ ఇలా కవర్ చేసి, సో దీనికి గివ్ లైక్ దిస్, ఇదంతా ఒక కవర్ చేసి ఉంటుంది, దీని లోపల టొరాయిడ్ ఉంటుంది. ఇలా ఈ టొరాయిడ్ విల్ హెల్ప్ టు యాక్సలరేట్ ద పార్టికల్. సో ఈ కాన్సెప్ట్ ని దే విల్ యూజ్ ఇన్ పార్టికల్ యాక్సలరేటర్. ఓకే, ఎస్, accelerated charged particle in spiral path, it is very high speed. Yes, we discussed that one. And some important points on toroid. And the class. Just take the problems directly. On the problem on the toroid. So here they have given that a long solenoid. So they have given a long solenoid. It has 200 tons per centimeter. Okay, and which carries of 2.5 amperes of current. They are asking that what is the magnetic field at center. They are asking what is the magnetic field at center. So see, they already given solenoid is number of tons per centimeter. Ante manaki em ichadu ikkada, they have given n value and they have given I value. So what is that magnetic field? Mu naught ni. If you substitute mu naught is equals to 4 pi into 10 power minus 7, and n is equals to 200 tons, and it is going to be 2.5. So we will get the answer. So nearly 6.3 into 10 power minus 12 Weber per meter square, or it's going to be Tesla. We already know this. The basic question we already discussed this one. And the second question. Last class we discussed this problem. Oh, sorry. And take this question, the second question. In the figure, they are showing the cross-sectional view of the hollow cylinder. Write the question. Hollow cylinder conductor. With inner radius R and outer radius 2. Cylinder carrying so uniformly distributed along its axis. Cm to meter. S and Cm to meter. Minus 2 minus 2 is going to be plus 2 axis. A magnetic induction a point P at a distance 3r by 2 from the axis of the cylinder will be. So I'm giving this image. So this is they're giving the toroid and the radius is given r. They're giving and is this. Okay. So for this, so we have to use the formula this one. The magnetic field is equals to, for the two radiuses are there, so mu naught I by 2 pi r and ra square a square divided by b square minus a square. So okay everyone, so we'll meet in the next tomorrow class. Okay na? Sir, chemistry sir is teaching chemistry. Yes, Sunday. So I was also, lots of issues are happening here. I was teaching outside of the room. No. Actually, I was teaching from outside. Outside, I'm teaching actually, not in the room. In the room, some other sir is taking. So, yeah. I'm teaching outside of the room only. Not in the room. I'm taking outside. So everything is messy outside. Okay, guys. So please excuse for today class only. No class now. Yes, Sunday. We don't have any class today. We will continue the classes tomorrow. Otherwise, I'm not going to take online classes for physics at least. Maybe I will take physics classes online only, offline only. It's not for online కుదరట్లేదండి. For me, it's not good. The situations here is not at all good. Virtual, yes, that's the ఏది బెస్ట్ అండి, ఆఫ్లైన్ ఆన్లైన్? No, Toyajak is not about suddenly because now here all faculty are teaching. All faculty are teaching here, and some faculty is teaching in the room. I am sitting outside. It's not good for me. Now why I need to sit outside? So morning, that is also good idea. Morning, yeah. No. Okay. So at least for physics, I will not take. Okay, na? At least for physics, I will not take. Evening time, mostly I will take physics. Okay, and don't worry, I will take physics in the evening time. Okay, and we will take offline classes only, not online classes. I will talk to the management. I will not take the offline. We will take up to 6:30 offline only. Okay, and please don't mind anything. Toyajaks will talk tomorrow. Toyajaks, don't worry. And we have to satisfy. And I also have to be satisfied from my side also. Okay. Okay, Bhagya Harshit, we'll discuss. Mostly take offline classes only, not online classes. Okay. Thank you very much, Andy. So please understand my situation also. We'll talk tomorrow. Okay. We'll continue the same class tomorrow. Don't worry. Okay, we'll continue the same class tomorrow. Thank you very much, Andy. Bye. No morning, no Bhagya Harshit. Morning. We'll see morning మనకి కుదిరిద్దా, మనకి ఈవినింగ్ కుదిరిద్దా. So we'll talk with you also. According to that, I will plan. Okay, na? Bye. Okay. Okay. Thank you. If you have any questions, just you can ping me. We'll talk in the WhatsApp. Okay. Bye. Okay, Harshit. Nice. Bye, Dan. Bye, Harshit. Bye, Harshit.